Now, to use this relation to determine the domain, the range, and whether the relation is a function, here's what I would recommend doing. I mean, you could graph it. It's going to take you a lot longer than this method I'm going to show you. I'm going to list the domain here, which will be 3, 4, 5, 6, 7. Well, that's convenient. They're already in ascending order. 3, 4, 5, 6, 7. The range I'm going to list underneath it, and the values of the range are 5, 8, 10, 8, and 9. 5, 8, 10, 8, and 9. So 5, 8, 9, 10 in ascending order. 5, 8, 9, 10. And then I start mapping. So input of 3 goes to 5. An input of 4 maps to 8. An input of 5 maps to 10. An input of 6 maps to 8. And an input of 7 maps to 9. Is this a relation of function? If you're saying no, I understand why. Because you see two values going to one value. But let's go back to the definition of a function and read it very carefully. Does each member of the domain map to one and only one member of the range? Does 3 go to one specific member of the range? Yes, 3 goes to 5 specifically. Does 4 go to one specific member of the range, or item in the range? Value, I should say. Yes. Does 5 go to a specific value in the range? It specifically goes to 10. Does 6 go to a specific value in the range? Yes, it goes specifically to 8. It's not like 6 is going to 8 and 9. 6 is going specifically to 8. You can have more than one value of the domain going to the same value of the range. You just can't have one value of the domain going to two values in the range. And I know that's going to be confusing, but I'll graph it also and show you. 7 goes specifically to 9. This is a function. Now, I wish I had thought ahead and made a coordinate plane, but at the same time, sometimes it's helpful to realize that you can just make one really quickly on your own. I've defined an origin. I'm going to be going all the way up to 7 for x, so 1, 2, 3, 4, 5, 6, 7, and y goes all the way up to 10, so 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 5, 4, 8, 5, 10, 5, 10, way up here, 6, 8, and 7, 9. Now, get a different color. If I draw a vertical line, right now I'm intersecting no values of the, I'm intersecting no points in the relation. Here I'm only intersecting 1. Here I'm only intersecting 1. Here I'm only intersecting 1. Same here, same here. So it doesn't fail the vertical line test. If there was such a thing as a horizontal line test, it would fail. But there is no horizontal line test. And let me explain why. If I go back to my dieting example, would it be possible for me in week 4 to have lost 8 pounds? And then again in week 6 to have lost 8 pounds? Yes. You can have the same output for 2 different inputs. You just can't have 2 different outputs for the same input. I don't want to overdo it, so I think I've explained it as best I can. I know that's going to be challenging at first, but the more you think about it, and and one of the many advantages of the video is you can go back and try to make sense of this again if you like. Okay, and lastly is this idea of a function rule. So if, for example, if x was our domain, our input variable, and we're adding 5 to the input, x plus 5, we could write y equals x plus 5. For example, if x was 1, I would add 5 to that and I would get an output of 6. But you can also use something called function notation. The function f in terms of x is x plus 5. This means the same thing as y. It's just when you see function notation, it's recognizing that you're working with a function and your input is x. It's sort of like it puts the input variable in parentheses so you understand that you're dealing with a function based on the input values of x. Whatever you input for x gives you the value of the function at that input value, which is why when you see this ordered pair listed this way, x comma f of x, it's the same as x comma y. F of x and y are interchangeable for now, but you're going to start seeing this function notation. You don't have to name it f for function, you can name it function g, so you could have different letters representing different functions, and you started to see some of that on last night's homework on the problem that we did on the video together. I did that intentionally. So the function f of x equals x plus 5 is read just the way I just did. F of x, the function in terms of x, f of x equals x plus 5. And to evaluate the function at a given value of the domain, just substitute the value of the input, the domain value, into the function. So when x equals 1, if f, I should write this above here, f of x equals x plus 5. So f of 1 means the function when the variable, when the input is 1, when x is 1. So you just substitute 1 for x. The function, the f of 1, the function at x equals 1, would be 1 plus 5 or 6. It's no different than when we say y equals x plus 5, but I want to check it at x equals 1, and so you just put 1 in for x. In a way, it kind of avoids this because we're saying what the input is just by putting it right there. F of at x equals 4, we would have f of 4, so that would be 4 plus 5 or 9. So f of 4 would equal 9. That would be the output when the input was 4. Okay, I looked at the assignment for tonight. I don't think, based on the notes that we've just done, which I know were quite extensive, I don't think you need any additional information to do well on the learning opportunity, so class dismissed.